Welcome to The Explainer. Today, we're stepping into a world that literally builds the foundation of modern society, metallurgy. Now, I know, that sounds kind of dense, maybe a bit academic, right? But stick with me, because we're going to break down how we classify iron using a super beginner-friendly and honestly highly unexpected analogy. Let's look at exactly how these metals are categorized.
So here's a question for you. What liquor should we drink after watching an opera? Yeah, I know, you didn't tune into this explainer for drink pairings. You're probably wondering why on earth a lesson on industrial metals starts with a post-opera beverage, but just hold on to that thought because it's actually a pretty clever little trick to lower the barrier into what is usually a highly technical subject.
All right, so the ultimate post-opera drink, at least according to this neat mnemonic device we're looking at, is called Sun Gangju. Say it with me, Sun Gangju. Picture it. You go out, see a great opera, have a fantastic time, and afterward you kick back with a glass of this specific, completely imaginary liquor. It sounds kind of funny, but this fictional drink is actually a masterful tool for beginners to grasp the absolute core of metal classification. So, what does this liquor actually represent in the real world?
Well, let's dive into this and reveal the big twist. Sun Gangju isn't a liquor at all. No way! It's actually an ingenious acronym for the three fundamental categories of iron materials. Sun stands for sunchol, which translates to pure iron. Gang is for gangchol, meaning steel, and Ju stands for juchol, which is cast iron. Sun Gangju, pure iron, steel, cast iron. Boom. Just by remembering this silly little drink, you've already memorized the three major pillars of metallurgy.
Okay, so if Sun Gangju is our metaphorical liquor, what exactly are the ingredients? Well, there are 5 basic elements in the mix here. Right at the absolute foundation, we have iron, chemically known as Fe. And it's combined with a handful of other elements, primarily carbon, along with some silicon, manganese, and a couple of others. But here's the thing. While iron is obviously the bedrock of all this, there is a secret agent hiding in this list that actually runs the whole show.
95%. Let that sink in. In almost all the materials we're talking about today, whether that's pure iron, steel, or cast iron, the actual element of iron makes up over 95% of the total composition. That is a staggering majority, right? And yet, they behave completely differently in the real world. Think about it. If they are all overwhelmingly made of the exact same ingredient, what actually causes these three categories to have entirely different identities?
So, the crucial point is, it's that remaining 5%, actually usually way less than 5%. While iron takes up 95% of the room, it's this tiny, almost microscopic fraction of the recipe that dictates absolutely everything. And that fraction belongs to carbon. It's not the iron that determines if something is steel or cast iron, it's the carbon. Honestly, it is almost unbelievable that such a minuscule additive can have such a domineering effect.
Section 1, the criterion. Or as I like to call it, the sheer power of carbon. Let's look at the actual structural map of our Sun Gangju analogy. First up, pure iron, or sunchol. For a metal to be considered pure iron, its carbon content has to be practically non-existent, specifically under 0.025%. Now, cross that tiny threshold, going up to 2.0% carbon, and you get steel. That's the absolute sweet spot for most modern construction. Finally, from 2.0% up to roughly 6.67% carbon, the metal officially becomes cast iron. Just a shift of a fraction of a single percent fundamentally transforms the very nature of the metal. Crazy, right?
Moving on to Section 2, real-world application, the bolts holding us together. So why does this all matter outside of a textbook? Well, knowing your metals means looking at a heavy-duty bolt on a job site and definitively identifying whether it's pure iron, steel, or cast iron. Guessing? Well, guessing means looking at a pile of bolts, assuming they're all just iron, and using them completely interchangeably. And because we now know just how drastically that little bit of carbon changes the metal's properties, guessing is incredibly dangerous. Like, a cast iron bolt might literally shatter under a specific type of pressure that a steel bolt would just easily brush off. Distinguishing these materials isn't just trivia, it's a vital safety tool. Understanding these materials helps prevent accidents before they happen. That right there is the ultimate takeaway. The entire reason we use analogies like Sun Gangju and the reason we go through the trouble of memorizing exact carbon percentages is to empower ourselves with knowledge that keeps people safe. When professionals know precisely how to classify and handle these different types of iron, they actively prevent disastrous job site accidents. It's knowledge that literally saves lives. So I want to leave you with this final thought. Take a look around you right now. Seriously, whether you're sitting at a desk, maybe chilling in a coffee shop, you are totally surrounded by engineered metal structures. Based on what you've learned today, what do you think they're made of? Are the bolts in your chair pure iron? Are the beams up in your ceiling steel? Think about those invisible carbon percentages locked inside them all, silently dictating how they hold up the world. Thanks so much for joining me for this explainer. Keep questioning, keep learning, and I'll catch you next time.